Hi, good afternoon, everyone. This is Kamil Zalewski from Unit8. Welcome to the Unit8 Talks, our webinar series on data and AI. Today, we're going to be focusing on MLOps, and this webinar is brought to you by Unit8, as we believe in knowledge sharing. We believe in helping, let's say, others close the AI knowledge gap. On the admin side, there's a small Q&A window on the right-hand side in the navigation panel. Feel free to use it to communicate with us. Feel free to ask any type of questions you might have. Without any further ado, I wanted to introduce Bartosz, our lead data engineer and also our MLOps practice lead, and he'll take you through the presentation. Bartosz, the floor is yours.
Thank you, Kamil. So hello, everyone. I'm super excited to see so many people joining here today. So a few words about me. So I have many years of experience with machine learning projects. I've been working there, having different roles of like software engineer, data scientist, machine learning architect, and a bit of DevOps. So this, I think, explains why I'm really passionate personally about the MLOps topic. And as Kamil mentioned, at Unit8, I'm leading MLOps efforts. So without any further delay, let's go to the topic of today's webinar. So today, no surprise, we're going to talk about MLOps. And the focus will be on how to increase speed of machine learning development, but still keeping the high quality of solutions. So, did you guys ever have had a trouble releasing machine learning to production? Let's look at the following situation. On the left side, we have a data science world where we obviously have CSV files, out of which we're gonna build some models. On the right side, we have prediction that we have to deliver to the user. So this is more engineering operations world. But in the middle, often we have a wall of confusion, actually. So let's look at this scenario. As data scientists, you firstly have to understand the data, right? So yeah, you check why we have missing values, what the different columns are meaning, what's the source of data, etc. And then you spend some time to do many experiments. Often it happens in Jupyter notebooks, where you try to build a model. So let's say you build a model, but it's just start of the journey. You need to productionize it, right? So it often happens by passing the model to the other side. And then engineer is taking the model and is asking some questions, obviously. So I have this model, but actually, how can I use it? I need to transform the data I'm having in the system so that I can feed the input data of the model. So this might be already a problem here. And so engineer goes back to the data scientist, and data scientist, yeah, I trained this model, but which model was it? Which version of code produced this model? And actually, which version of data I used? So I had many experiments in Jupyter here and there. Yeah, it can be difficult already to find it, but then eventually you solve this problem, you help engineer understand everything, and then engineer, let's say, succeeds to deploy it. I know I made a simplification here, but I just want to keep this story shorter. So let's say we deployed the model, but wait, why we have different results on production than we had before during training? So here, engineering goes back to data scientists, and again, we have a situation that, oh, it was a few weeks ago, it's difficult to find everything so that I can help you. So let's think how to make this better. So today we start with introduction to the main concept of MLOps. Then we're gonna see how MLOps practice is held throughout the machine learning lifecycle, and then how to start with MLOps. And at the end, some next steps. So MLOps helps to get machine learning to production. I know that it's a brave statement, but let me talk why it happens that way. So we start with a definition. So MLOps is a practice. So if you hear about it, it's not just one tool, it's not one process. So as a practice, it's naturally a set of tools and processes. But practice of what? So it's a practice of collaboration and communication. Here, these are two very important keywords when we talk about MLOps. So it really is about collaboration and communication. But again, about collaboration and communication between whom? So in the center, we have data scientists. Obviously, they train models, but they need help to release them. So they need other IT teams to help them and to help with managing the end-to-end machine learning lifecycle. So now let's look from the other angle. So as I mentioned, communication is key to success. But as we have data scientists in the center, and they are responsible for model development, they need data to build the model. So we have a data acquisition before, and here probably is already data engineer responsible for that. But what kind of data? So we need some business input, right? Some business idea what we try to solve. And here we also need someone from business side, namely subject matter expert, that can define the problem we solve and also communicate it further. So now let's say we have the model and we need to release it. So we have a model deployment step where we have already different people involved, namely software engineer and often DevOps already. And once we have a model on production, it's not the end. We have to monitor the model. So we, again, need DevOps help to set it up. We need data scientists to have data scientists input about what kind of metrics we check while monitoring. And also, it's good to have help of subject matter expert here to know about business metrics. And once we have this monitoring, we need to close the feedback loop so that we go back to model development whenever we need to train a new version of model. So the main concept and the main message that MLOps is saying is to break silos between teams so that the communication is improved. So if we have those groups of engineers, it's better to structure the projects in a way that we have cross-functional teams so that they can communicate much easier, update on the daily status, and work in a more agile way this way. Okay, so I think we can go to the model development part, and let's look at this following situation. Here in the pipeline, we have data extraction analysis. So firstly, data scientists need to understand the data, then prepare the data, train a model, and finally evaluate and validate. So I think that data understanding, like the first step, is not repeated that frequently. So once you have understanding, then you're gonna have some iterations further. We can define that three steps on the right side are an experiment. Because if you train a model and evaluate, maybe you want to improve by changing hyperparameters or maybe changing algorithm you used, or maybe you go step back and you change even how you prepare the data to train given algorithm, or you create new features basically. And when you do so many experiments, it's really worth you if you invest time in tracking those experiments and versioning, because it's gonna save time later on. So if you have just one data scientist, he's gonna work, let's say, in the Jupyter notebook to train a model. And then, maybe I have an idea to use different algorithm. So maybe let's do it in different Jupyter notebook. And then maybe I want to check different features. So let's make it in different Jupyter notebook. And then, oh, I have some repetition of code. Maybe I extract it to Python script and run from there. So it easily gets more and more complicated. So even if you work on the Kaggle competition and you are just one person, it may be already worth to track those experiments. Situation becomes even more complex if there is a second data scientist working on the same problem. But what if we have bigger team? So it's very difficult to manage it. That's why it's very important to track all experiments, because this way you avoid repeating work between each other. So basically, otherwise everyone could write similar pieces of code to do similar things, or even try the same algorithm with similar hyperparameters. So like there can be a lot of work duplication this way. So when we track everything, we have clearly describe experiment and under project we solve. But here it's not that straightforward, because like what does it mean? Does it mean that we only save what things we tried? So let's explain it a bit better. So when we talk about experiment, it's not only code. Like in software development, we have code. Here we also deal with data. So basically, it's worth saving what kind of code and what kind of data you use during experiment. And that's also not all, because you use some packages, libraries. They have also some versions, and you use some parameters. So basically, you should save everything in this kind of system. So this brings us to versioning. So if we save what we did with versions we used, we gain reproducibility. So this way, anyone in the team would be able to reproduce each other's experiment and make things faster. So this also is very helpful when you're debugging some problems, when you hand over model to engineer and then you need to debug something later on. That helps with auditing, like if you want to know how exactly given model was created later on. So another very important message is to centralize everything so that you improve collaborations and speed. So here you might wonder why I brought a shopping mall image on the right side, because there is actually some analogy. If you need to go shopping, you need to go to, let's say, 3 shops. Normally, you would have to check where they are and lose some time on commuting or driving between them. But if you have a shopping mall, you have all these shops in one place, so you can do shopping faster. So actually, with machine learning, it's similar. If you have all the data sets, experiments, everything in one place, it's much faster to do things and also easier to collaborate. So here we're talking about having a shared environment between data scientists, engineers, having a shared code, data sets, experiments, and last but not least, models. So this is kind of like having a platform if we centralize everything. So I think now it's a good time for a poll. So I would like to ask you, actually, why don't you track your machine learning experiments? So maybe you track them. Maybe you think it's too much overhead on your work, or it's too complicated to set it up. But maybe you actually didn't consider it, or you're not working on model development. So now you should see a pop-up window where you can vote. So let's give like a half a minute and collect feedback.
The poll is now launched. I see the answers coming to us. Let's give it maybe 15 more seconds for everyone to fill in. Okay, I see most of the attendees have already filled in, although the answers are still coming. So maybe a few more seconds before we close the poll. Okay, I think we have most of the people who've already voted. So I'm going to close the poll, and Bartosz, you should be able to see the results right now.
Oh, that's really interesting. That really many people are tracking already experiments. So that's great. For those who are not tracking it, and it's still 44% that are working and not tracking, I would like to show quickly that it's not that difficult to do it. So basically, there are already tools out there that can help you a lot with that. And I will show you an example where you just add 2 lines of code and you have this tracking and reproducibility almost for free. So this is your Keras code, like often can look this way, that you just want to train a neural network and do a couple of iterations over epochs. And if you want to add tracking here, there is, for example, a tool named ClearML. You just add these 2 lines of code, you import task and you initialize it. And what happens then under the hood, it gathers everything, and you get a dashboard where if you run for the first time, new project is created, and you can go inside the project and see, like, with each run, you have a new experiment created where you can see like which version of code created that, like who initiated it, when it started. But what is also very cool is that you can have out of the box some metrics gathered and parameters used. So then you can go even further into detail and have a view of single experiment and see how it performed over iterations, so when epochs were running. So this is just giving you few information what you can find in this kind of tools, but it can give you much more. So I really encourage you to check it out. So now we can go a step further. We were talking about experiments, and let's talk now about how to centralize models. So MLOps is saying about concept named model registry. This should enable to scale machine learning efforts easier, actually. So let me tell you why. So we have model registry in the center, right? And then how to connect this with experiment. So results of the experiment are following. We have some artifacts. Once we train a model, we may have some artifacts like, okay, this is a model, this is like a testing data set, these are the plots that I produce, etc. But also you have some metrics. And from those artifacts, you may want to register a model or not. We're gonna come back to it later. And then if you have models in the model registry, what we are really interested about are things like which experiment created that model so that you have a full lineage, which version of model is it, which tags are associated, like some classification or whatever, which stage is it. So you can, for example, transition between the testing environment and production here. And now we can talk about model deployment. So here, I think already the testing phase and the clarification when to register in the model registry can be under this model deployment, because this is how we can ensure high quality of models that are released to production. And let's think about this scenario. Does it make sense to have any guards before registering a model? Because maybe it's good to have all the models trained in the model registry, but we can think about it like, okay, if we have those models already on the experiment level, maybe let's have very clean version of model registry and really validate things before pushing there. So what could we validate? For sure, we could validate statistical properties, for example, accuracy. So it depends what are you really try to optimize for. You can compare with the previous version of a model for a given problem, if you had one. And you can check consistency on various data segments. And now let's try to give me a practical example of it and clarify it a bit. So for example, with statistical properties, you may want to enforce that accuracy is always higher than 90%. If you trained a model before for this problem, you may want to have an accuracy that is at least equal than the previous version. And now the consistency on various data segments, what I mean here is like we can have feature, which is the region that refers to customer. And for example, okay, we have high accuracy because majority of data is from one region, but you want to have very high accuracy in each region. That's why you might want to validate on different data segments as well and say for each region, it has to be at least 88%. So if you enforce high quality this way in the model registry, you can make a process that you release models to production only from model registry. So this way you could really enforce high quality solutions. But there is something missing here. So we see some new trends like fairness that we also should take into consideration here. So let me give you an example. So we can have a feature which is gender. And if we do not check that we are not biased by gender, it can be quite harmful. And now let's go to the interesting example. So what you see here is an Apple credit card. And obvious question would be, is it high quality product? And you may think, yeah, okay, it's coming from Apple, probably, yeah, big company, probably it's high quality, right? But there's one surprise here. Here's a tweet from Steve Wozniak, who said that he and his wife have no separate bank accounts or credit cards or any assets of any kind. And they also have different credit cards from different providers, and they always have the same high limits. But in case of the Apple credit card, he had 10 times higher limit than his wife. So this is quite surprising. And actually, this is where Apple failed on fairness. And there were US regulators who are now auditing why the algorithm behaved that way, and they are having some troubles. And so this is just one example that you might also need to consider this depending which use case you are solving, because it can be pretty harmful for your organization if you don't do it. So I think we can go now to the monitoring and feedback loop, because let's assume that we release model to production and talk about monitoring.
And Bartek, maybe, Bartosz, before you move on, I mean, you didn't really cover the part of bringing the model from model registry to production. I mean, are you able to elaborate a little and say a few words before we move on to the next stage?
Yeah, I initially thought about skipping this and focusing on other parts more, but I had also a slide for that. So maybe let me jump to this one. So if you want to release something from model registry, which you have here, you should follow, like, this is more or less the standard DevOps CI/CD pipeline, where you would firstly release to testing environment. So basically, here depends on the situation, because it can be that you didn't have any model yet, so it's a bit easier. You just can create a new endpoint for it, right? Or just prediction service. But it will be becoming more difficult when you just want to release new version. This we'll see soon. But when we release to testing, we also want to do some more tests. So basically, we want to check other properties like average latency or 95 percentile of latency, because in some use cases, it's very important that we are also doing predictions very quickly. And another thing that should be done on the testing is could be done, it depends on the process, is QA checks. So just to give practical examples, here we would check about average inference that is below 100 milliseconds, or that less than 5% of inferences take more than 200 milliseconds. The last one is if we get QA approval, we go further. And this is what I was mentioning. What if we have already some service on production? So there are two practices that are widely adopted when you want to be really safe. It's either to do shadow or canary deployment. So shadow would be that you deploy your new prediction service, but it's not really used to provide feedback to end user. You can, at this stage, just compare how it would behave comparing to your main model. And canary one is that you just forward few percent of traffic to the new service with new model, and the rest is still with the old model, current model. And then when you validate that it's really better, then you forward more traffic. So this would be closing the gap. So now let me go to the monitoring. So what really matters here is to be able to react fast when model performance drops. Here we have also two dimensions. On one side, we need to monitor resources like CPU or memory, what happens when we have more traffic, for example. And on the other side, we want to make sure that what we predict on the top is really very close to the ground truth. So this is about checking the metric that we are optimizing for, that it's still close to what we were seeing on the training side. And here, if we want to do it, we need to log all incoming data with metadata. So basically, for all new data that comes, we should log what kind of prediction we have done, maybe with some metadata about like what was the probability, etc. Like log what was the response time, so that we can analyze it further. And once we have this everything, we can set up some alerts. So either it's on our resources or the metrics. So it may seem to be really easy, right? We have prediction, ground truth, we just measure if the metric changes, and that's it. But reality is not that easy, because often we don't have ground truth. Or maybe we actually may have ground truth, but think about scenario, you're predicting if someone, like when someone has seen advertisement, if he downloaded application or opened bank account. Like the outcome of it can happen like in months. So you really would like to know earlier if something, if your model is still of good accuracy, let's say. But there is a solution for that. You could monitor input and target distribution change. So let's say you use age as a feature, right? So when you're training your model, the reality is like with the blue color, that you have rather younger people. And I know it can be an exaggeration here, but what may happen is that the distribution can drift. It's often named data drift. Like when you release your model, like the new data that comes may have already different distribution of the features you use for training. So in this case, you would have older people. So if you think about the modeling side, so you model this reality where people are younger, and then you predict in the reality where people are older. So this already gives you some insights that your model actually might not be that accurate as before. So what you should do, you should compare these distributions for all features. And then you can combine it with the feature importance to set up some alerts. But also, it's very important to measure target drift, because let's say you have a situation that you try to come up with the credit score. And in this case, maybe you started predicting lower credit scores in overall. And that can be, what can be an outcome of it? Well, business gives fewer loans to people. And because of that, business earns less. So like not only the features itself matter, but also the target variable which we predict. So this brings us actually to the next topic, that we should, if that's possible, have a business metric that we can use to decide about retraining. So if you think about closing this feedback loop, when should we retrain a model? So on one side, if we think about new model, it's gonna cost, right? Because many people are involved many times to train a new model, and you need a lot of resources sometimes, GPU, TPU, whatever. So it's gonna may cost a lot of money. So it's good to be aware how much this process costs, so that you can decide, like using this business metric, if you should retrain now or not. So let's take again this credit score prediction. So you don't really have ground truth information in this case. So let's say you have an input drift, which is an borders limit that you specify. But if you have this kind of business metric that says, okay, but number of loans didn't drop. So maybe this can already help you decide that we can wait a bit longer and see what happens. So this is the scenario where business metric actually may be helpful. Okay, so now I would like to talk about how to start. So as always, when we start something, we should be quite careful, and we really should identify our needs. What I mean by that, we shouldn't invest too much money in like fully fledged platform that gives you all the possibilities, where you just have small data set and want to train a simple model. So I would name here three dimensions. One would be the data science department size. Another would be how frequently you need to retrain models. and yet another degree of sectors AI regulations. So let's take a few examples. Let's say Uber Eats, right? They have problem. They want to predict time to deliver food. So in their case, this is probably not really regulated field because, well, if you're late 10 minutes, someone will not die probably from being hungry. But on department side, for example, I think there will be a lot of people working on it. And in terms of how frequently you need to retrain model, it's gonna be also quite frequently because we have new businesses that take part in the Uber Eats. So you have to make sure that you have all the data under model up to date. So I would say that here we need a weak governance, fully fledged platform because many people gonna work on it, and we need to frequently retrain models. So also full automation would be helpful. On the other hand, we have a credit score problem, and here it's very regulated sector, but probably you don't need to retrain that frequently. So what changes here is a strong governance. Again, many people working on it, so probably fully fledged platform, but we might need just partial automation if we don't really need to retrain frequently. Okay, so I think we can go further. What are the best practices then? So I think here we can
maybe Bartosz, if you don't mind, because there's one more question, because you mentioned the needed level of governance as degree of sectors AI regulation. Can you actually maybe add a few comments on model governance? What is that?
Okay, yeah, I think it's yeah, exactly. It's worth clarifying. So here, what is governance? It's quite a broad topic. So I will try just to be short about it. In a nutshell, it's just about set of controls that are placed on businesses to make sure that they are deliver responsibilities to all stakeholders. By stakeholders, here we mean like not only employees, investors, but also the public and governments. And what kind of responsibilities? It can be few different types. It can be like financial responsibilities. So in regulated sectors, you need to have, for example, model risk management, all the processes around it. From legal point of view, for example, you need to be compliant with GDPR. In different sectors, industries, you may have different regulations. And also I know that there is a work right now on some AI dedicated regulations. And also there is ethical concept here that your solutions, for example, should be fair, as we were looking at Apple credit card scenario. I hope this answers your question, Camille.
I think yeah. Thank you for that.
Okay.
And thanks. I'll take, as you're having a quick break, I'll encourage the attendees to leverage the questions tab for asking questions. Yeah, Bartosz, please carry on.
Yeah, so now I'm gonna give you a few best practices. So I will just collect those that we are talking today about, and they should be very helpful when you start with MLOps. So what is it about? It's about having cross-functional teams. It's about tracking all experiments. It's about investing in reproducibility of models. It's about centralizing all assets, validating models, releasing only from model registry, monitoring performance, and retraining when needed. So those, I think, would be really best practices of MLOps. And what would be the next steps? As we have limited time today, I actually skipped a few concepts that are common in MLOps, but I cannot talk about everything today. But I would like to mention one thing that we would like to present in the future, be it in the webinar format or maybe an article. So what would be really interesting is to see, like, on the real use case, how we're gonna progress to the full automation of the pipeline. So here that we really see, because it's possible to actually have a full automation from model development to releasing of the model, monitoring and closing the feedback loop. So this is what you can expect to be coming in the next months. And one more thing that I would like to mention, some reading recommendation. So there is really nice introducing MLOps book from Dataiku, published under O'Reilly. I also seen some interesting ebook from Valahide, and you can find Google's MLOps article, which describes different levels of MLOps and how to implement them. So right now, we should still have a few minutes for questions, right, Camille?
Yes, that's correct. There's a few of them in the questions tab. One of them is around the fact that there's actually quite a lot of new acronyms flying in the air: the data ops, the ML ops, the AI ops. Are you actually able to maybe explain the main quickly the main differences between the concepts?
Sure. Yeah, I know it can bring a lot of confusion when you start diving into MLOps and then see so many other ops. So basically, MLOps, as we were saying, is about bringing end-to-end machine learning to production, like managing end-to-end machine learning. Like when we talk about data ops, it's about having business-ready data of high quality, so that you can quickly use business data. And here would be a connection to MLOps in a way that data ops can, for example, let you know that because it's also about collecting metadata about data. So it could let you know that data set on which you have trained models has changed significantly, and maybe you should react with models. You should retrain models because the data set, base data set has changed. When it comes to AI ops, for example, it's more about solving operational challenges using AI. So it's more like bringing AI to DevOps, so that it's like predictive maintenance. So for example, you try to predict that there will be a network failure before it happens. So you don't wait until it happens and you have an alert. You set up an alert when you predict that it's gonna happen. And there is also model ops, as I'm aware. It's a more generic term on MLOps, which is about all models, not only machine learning models. So does it answer your question?
Yeah, there's more question, but I'll add one more comment that in the recent report by Gartner about the latest trend, I've seen the concept of XOps, where I guess X stands for anything that you want to put over there. But on a more serious note, there is a question from Andrea. What are your favorite frameworks for MLOps?
Yeah, that's a very good question. So actually, if I don't use cloud, then I used to use MLflow, which gives you quite nice tracking capabilities and has model registry. But recently, yeah, we found this ClearML, which actually has many things much more simplified than MLflow. So we are kind of transitioning to ClearML with what we use. And in terms of cloud solutions, actually we see the best working Azure ML Studio. So we're also comparing like Google AI platform and SageMaker, and Azure ML Studio is like working really nice. And also you have there already in beta version, I think, fairness implemented and explainability. So it's really quickly evolving.
Perfect, and I think there's a little bit of the follow-up question piggybacking on the previous one from Hussam. Can you please list and maybe compare some of the other tracking experiment tools like ClearML, MLflow? I think you touched upon that in your previous answer.
Yeah. So with ClearML, you theoretically can write fewer lines of code than with MLflow. And what I think is the future here is that you have a tool that you really have these like few lines of code, and that you have everything done by you instead of doing yourself. And like the biggest difference I would say is that with ClearML, you can for example submit like your experiment without executing it. So there is a bit different architecture under the hood. And on the UI level, you can really change all the parameters you use. So you can run like all those experiments from the UI point of view, not really that you have to do this programmatically. So I think this is very handy, and this is what you cannot do in MLflow. And would there be something else that I really like much more? Yeah, I think it's also worth mentioning that ClearML doesn't have that well done model registry yet. So they rather have all the models on the experiment level, but you don't have a link to model registry. So you cannot really, you have to have model registry separately there. So this is what you get in the MLflow, but you don't have in the ClearML. So do you have maybe any more specific question about like differences, or does it satisfy your question?
Let's see if we get the answer to this one. I mean, I posted my email as well if anyone wanted to follow up, because we probably won't be able to cover all of the questions. There's a question from Sebastian as well. What about the Kubeflow ecosystem?
That's a really nice question. And I'm laughing because, yeah, I gave it a try. And Kubeflow, to be honest, it's really an overkill if you are just starting with machine learning and MLOps, because to have it working, really working, you need to use Kubernetes, and it's a lot of services it deploys for you, and it stops working. Like when you try to use it, suddenly you have pods that stop working. So they try to combine everything in one place, but it's not really easy to use. And also, if you look at the documentation, it's very outdated in some places, so it's not really easy to start with it. I know that some companies are using it, like Spotify, but it's not really easy to start with journey with it. But it's worth mentioning that from Kubeflow ecosystem, there is one part which is Kubeflow pipelines, and this pipeline, this part was extracted from the main project, and this is what is now hosted in Google AI platform, so on cloud. And this is something that actually works quite nice. And there is a concept there where you can split your entire machine learning development pipeline into pieces and have it written in the domain specific language, like provided by Kubeflow. And then you have few boxes that you can execute separately, and you can repeat things on only a few things that you want from the pipeline. So this part is really nice, and you can easily try it on the Google Cloud.
Perfect. Thanks, Bartosz, and maybe thanks everyone for all the questions. Maybe we have the time for the last one before we finish the webinar. A question from Matthias. What's your perspective on using MLOps in the cloud versus in the hybrid environment versus on-prem?
So to be honest, I think majority of companies that are right now still on-prem will rather migrate to cloud, because you cannot easily keep up with developments on cloud side. So if you want to have your own platform, build your own platform, yeah, and deploy it on-prem, then what happens if you suddenly have a new tool that you want to support, and if you have bigger data and you need more machines? Like with cloud, you have it very quickly done, and if you're locked on-prem, it's gonna be more painful to do that. So I think as time goes, companies that still are on-prem will start migrating to cloud solutions.
Perfect. And I think being respectful of time of our audience today, let's close for today. In the chat window, I did send the link to our YouTube channel where the recording will be published. And with that, I wanted to say a very big thank you to all of our attendees. Thanks for tuning in to this episode of Unit8 Talks. Bartosz, big thank you for introducing us to the topic of MLOps, and a warm invitation to the next episodes of our sessions. We're trying to come to the market usually at least every 3-4 weeks with the next webinars. The next one will be end of March around the AI in chemistry. With that, have a great evening. Thanks a lot, everyone, for joining. Bartosz, thanks a lot for guiding us through the content.
Yeah,
Thank
thanks
you.
a lot.
All the best.
Thanks everyone for joining.